Good day, everyone! Have you ever imagined that something so tiny, even smaller than a grain of sand, can actually change the world? That's what our lesson is all about. By the way, I am Nikki Jean R. Altariba, and welcome to the lesson for the Nano World. This lesson introduces the nanotechnology, the science, engineering, and technology that works at an extremely small scale from 1 to 100 nanometers. So, the concept of nanotechnology is nag-start siya sa December 29, 1959, when physicist Richard Feynman discussed the idea of controlling atoms and molecules one by one in his famous talk, "There's Plenty of Room at the Bottom." So later on, ang term nga nanotechnology is na-introduce ni Professor Norio Taniguchi about a decade later. So even though nanotechnology deals with very small things, it make a huge impact in our daily lives kuno. So it's used by the medicine to fight sa mga disease and even in technology for faster and smaller devices, and even in agriculture to help grow healthier and to help the environment and more sustainable crops. So now that we have an idea of what nanotechnology is and where it started, so Villarin, how small exactly is the nanoscale and how what can we ever view nanomaterials?
How small are view nanoscales or material? Hello everyone, good morning. My name is Ana Marie Villarin. So when we say nanoscales or materials, so nanoscales and nanomaterials is 1 billion of a meter. The nanoscales is a range of size between 1 and 100 nanometers. Manipulation of nanomaterials is nanomaterials are materials that have parts within the nanoscales. That can be particles, tube, wires, films, flakes, or shells. So, how to view nanomaterials? Since nanomaterials are so small, special microscopes are needed to see them. Early scientists in the 1930s used electron microscope and field microscope. So speaking of that, Deloso, can you tell us what tools they use to view nanomaterials?
Oh, that's a great question, Villarin. But before that, let me introduce myself first. I'm JD Deloso, and I'm going to explain the tools they use to view nanomaterials. And there are 3 tools they use to view nanomaterials. The first is the electron microscope. What is an electron microscope? So an electron microscope produces higher and clearer images than the old light microscope. It can magnify objects up to 1 million times, while a light microscope can only magnify up to around 1,500 times. And there are 2 main types of electron microscope. The first is the SEM, or scanning electron microscope. It is used to see the surface of an object. So for example, the surface of an insect or the surface of a bacteria. The second is the TEM, or transmission electron microscope. It is used to see the inside parts of an object. So for example, they use this to view the inside of a cell, or like the nucleus or mitochondria. Now, let's proceed to the second type of tool they use to view nanomaterials. It is the atomic force microscope, or AFM. So the atomic force microscope was developed by Gerd Binnig, Calvin Quate, and Christoph Gerber in 1986. It uses a tiny mechanical probe that moves across the surface of a material to gather information about its texture and structure. For example, scientists use AFM to examine the surface of metals, gold, or computer chips. It also helps determine how smooth or rough a material surface is. Now lastly is the scanning tunneling microscope or STM. So the scanning tunneling microscope or STM allows scientists to see and manipulate atoms and molecules. It gives a detailed view of materials at the atomic level. So for example, scientists use STM and nanotechnology to move atoms and create new materials. It is also used to observe the atomic structure of graphite or carbon dioxide. So this microscope was invented by Gerd Binig and Heinrich Rohr, who won the Nobel Prize in Physics in 1986 for this discovery. So after seeing them, Shabok, how do scientists manufacture these nanomaterials?
Hello, I am Jerlyn Shabok, so I will explain about nano manufacturing. So nano manufacturing, it refers to scale up, reliable and cost-effective manufacturing and nanoscale materials, structures, device, and system. It is also involves research, improvement, and incorporation of processes for the construction of materials. Therefore, nano manufacturing leads to the development of new products and improved materials. Therefore, there are two fundamental approaches to nano manufacturing, either bottom-up and top-down. So kani si nano manufacturing kay nano. So nano kay kanang small. So manufacturing creation of new product. So manufacturing makes a development in new product. It is small. So example sa kanang top-down fabrication kay katong morning kanang gani lumber. So lingin pa na siya dayon himuon siya o kanang himuon siya 1 by 1 to mas 10 by 5 inana anang para so kaning bottom up fabrication kay it manufactures product by building them from automatic and molecular scale components. However, this method can be time-consuming. Scientists and engineers are still in search for effective ways of putting up together molecular components that self-assemble and from the bottom up to organize structure. So, kaning bottom up fabrication, kay ano siya ang katong builds on materials from small parts to larger structure. Okay? So, top-down fabrication streams down large pieces of materials into a nanoscale. This process needs larger amounts of materials and discards excess raw materials. There are new so mao ni siya ang katugaling motong lumber. So lingin pa na ang lumber. So nagmay siya, himo siya gagmay nga parang himo ang balay. So himo siya kanang 10 by 10, like 5 by 5, inana katong 2x2, inana mo na siya into sa dako padung sa gamay na pieces. Sabat nasa another kanang ko example ani kay ang kawayan, lingin ang kawayan. So gagmayon siya para mahimo siyang isalog. Risk. Can you tell me a technique used into nano manufacturing?
Good day everyone, I'm Faith Rubino Almares and my topic is method or techniques in manufacturing. Bottom up and top down. So I will first discuss the bottom up. Bottom up buildings from atoms and molecules. So this is the part of bottom up. Self-assembling. Molecules organize themselves into structures. And the second one is ALD or what we call atomic layer deposition. It deposits thin films with atomic precision. And the third one is directed assembly, guides nanoparticles into desired structures. And the last one is soft template and filtration, uses polymer templates filled with precursor solutions. So let's proceed to top down. Top down reducing larger materials to nanoscale. So this is the part of top down. Photolithography uses light to transfer patterns onto a substrate. And then the second one is ABL, or electron beam lithography, uses electron beams for high-resolution patterns. And then, NIL, nano imprint lithography, presses nano pattern stumps into polymer films. And then, deepen lithography uses an atomic force microscope tip to write patterns. The last one is soft lithography, uses molds to shape materials, good for medical uses. So Morales, what are some distinct features of nanoscale or what makes it special?
I am Morales Lovejoy, so now I'll be talking about the distinct features of the nanoscale, the tiny world where nanotechnology operates. So here are the three distinct features of nanoscale. First feature is the scale at which much biology occurs. Many biological processes take place at the nanoscale. For example, DNA is about 2 nanometers wide, and hemoglobin, which carries oxygen in our blood, is about 5.5 nanometers. Because of this, nanotechnology helps scientists create precise medical treatments and diagnostic tools. One example is the biobarcode assay, which can detect disease markers in blood even when they are present in every small amount. The second feature is the scale at which quantum effects dominate properties of materials. So, at the nanoscale, materials behave differently because quantum effects start to control their behavior. For example, nanoscale gold can appear red or purple instead of yellow. These properties make nanomaterials useful in medical imaging and targeted cancer treatment, where gold nanoparticles can destroy tumors without harming healthy cells. So the third feature is the nanoscale. Materials have far larger surface areas than similar masses of larger scales materials. When the surface area increases, more atoms or molecules are exposed and available to react. This makes nanomaterials more reactive and more effective in applications like catalysis, sensors, and drug delivery. For example, imagine a single cubic centimeter of material filled with nanosized cubes. Their combined surface area would reach up to 6,000 square meters. That's roughly the size of an entire basketball court from just 1 cubic centimeter of material. Amazing, right? So Pilan, can you tell the different countries who funding or support the nanotechnology?
Funding for nanotechnology in the different countries. So many countries like U.S. National Nanotechnology Initiative or NNI, established in 2001, aimed to create U.S. Federal Nanotechnology R&D, had a budget of $1.4 billion in 2008, and 2009 the budget of $1.5 billion. Your next European Commission launched with the European Nanoelectronic Initiative Advisory Council in February 2008. Next, other national initiative. First, Japan Nanotechnology Research Institute under EIST. Next, Taiwan National Science and Technology Program for Nanoscience and Nanotechnology. Next, India Nanotechnology Research and Education Foundation. Next, China National Center for Nanoscience and Technology. Next, Israel Nanotechnology Initiative. Next, Australian Office of Nanotechnology. Next, Canada National Institute for Nanotechnology or NINT. Next, South Korea, Nanotechnology Initiative. Next, Thailand, National Nanotechnology Center. And lastly, Malaysia, National Nanotechnology Initiative. What about in the Philippines, Laguna? Are we involved in the technology? Also tell me the possible application.
Yes, Mr. Sabilan, in the Philippines, the possible application of nanotechnology in the Philippines like ICT and semiconductors, using nanomaterials to make smaller and faster computer chips for phones and laptops. Nanotech helps to make device more efficient and energy saving. And the second one is health and medicine. Nanoparticles used to deliver medicine directly to the cancer cells. Nanotech helps doctors treat diseases more precisely and safely. And the third one is energy. Nanomaterials is solar panel to improve sunlight absorption. Nanotech support renewable energy and energy efficiency. And the last one is food and agriculture. Nanosensor detect food spoilage and contaminants. Nanotech helps ensure food safety and boost crop production. Now, Rosalina, tell me about the nanotech roadmap in the Philippines.
So, benefits and concern of using nanotechnology. So yes, nanotechnology has many benefits.
And also concern nanotechnology, the science and engineering of materials.
Devices on nanometer scales has the potential to revolution many industry. However, it will also bring us unique challenges. Here is the concern and benefits of using nanotechnology. Benefits of nanotechnology first is healthcare and medicine. Target drug delivery, diagnostics, and tissue engineering. Mao na sa nasa research can deliver drugs directly to disease cells, cancer cells, reducing the side effects. Sa diagnostics, nanosensors can detect disease early by identifying biomarkers and every small quantities.
Tissue engineering. Nanomaterials can help regenerate damaged tissue or organs. Second, electronics and computing, smaller and faster devices. Nano enables smaller transistor and memory storage, improving speed and the power efficiency. So, kabaw naman dito ni mga RAM, D, mga flexible electronics. Nanomaterials like graphene are used to develop bendable display wearables. Kabaw sa tala. Kaning samot na kaning katulo, energy efficiency. Solar panels kana kabaw gina kay ma-absorb man jud siya og init nya. Kanang nanomaterials increase solar panel efficiency by improving light absorption and reducing energy loss. Batteries kanang batteries nanotech and enhance battery life, charging and speed devices like phones and electronic vehicle. E-bike, environment application, water and mga filters.
Kanang makahawa og kwan kugaw sa kwan. Nya. Pollution Clean Up. Can break down toxic substances in air or water. Pollution. Nanoparticles. Kanang siya. Nya, stronger and lighter materials. Construction and manufacturing. Nanocomposites offer better strength to weight and useful in aerospace, cars, and sports equipment. Textiles. Nano can make fabrics water resistant, stain repellent, or antimicrobial. Concern and risk nano health and safety. Kabaka, natay ka ng mga health and safety ka mga amnon nga toxics. Basta toxic. Bala siya ka na makakuha niya. Environment impact. Sa persistence kanang may not degrade, easily leading to long-term contamination. Teacher lang. Kanang sa kaning kanang impact manay kaduha. Ang katulo, ethical and social issues. Privacy. Kanang surveillance devices could raise serious concern about the personal privacy. No, naman sa ko ng ubang tao nga privacy dyan. Kanya kanang using nanotech for human kanang mga therapy. Rin mo kaan daw kanang mga research ethical diabetes kanang sa mga kuan kanang using nanotech for human nga kuan therapy. Nya ikaw pat economic disruption, job displacement, automation and efficiency from nanotech may lead to the job losses in traditional industries. Makakuala ka na makapuli. Access inequality. High cost and complex might limit access to advanced nanotech in developing countries. 5. Regulatory challenges. Lack of standard. Development of space regularization. Living gaps in safety oversight. Labeling. Consumers may not know when products contain nanomaterials. Nanotechnology holds immense potential across many fields but must be developed responsibly, balancing innovation with safety assessment, ethical consideration, and transparent regulation will be key to maximize with its benefits while maximizing its risks.
So before we end our presentation, let's quickly summarize the key points we discussed in Lesson 4. So the Nano World. First, we learned that nanotechnology is the science and technology that works at the nanoscale from 1 to 100 nanometers. Second, we understood how small the nanoscale and how scientists use special microscopes like electron, atomic, and scanning tunneling to view nanomaterials. So the third, we discussed how nanomaterials are made through method like bottom-up and top-down fabrication, using techniques such as self-assembly, nano-imprint lithography, and deep pen lithography, and roll-to-roll processing, and many more. We also learned about the unique properties of nanoscale materials and how the nanotechnology is applied in medicine and also sa agriculture, energy, and even sa mga environment to make our life better and more efficient. So in conclusion, Lesson 4 taught us that even though nanotechnology deals with extremely small materials, its impact on our lives or our world is truly massive. So it continues to shape modern science and also improves our way of living and open endless possibilities for innovation. So si nanotechnology remind us that even though nga ang smaller things is nag-give og biggest changes. And that wraps up our discussion on Lesson 4, the Nano World. Thank you for watching and learning with us.